Today we're going to review interior and exterior angles of polygons and then talk about ways to prove quadrilaterals in coordinate geometry, do different proofs. So for interior and exterior angles of polygons, when we have a polygon, here I have a 1, 2, 3, 4, 6, a hexagon. If I want to figure out the sum of the interior angles, here's how we go about finding the formula. For every polygon, I can create triangles, and I can always create 2 less than the number of sides, 1, 2, 3, 4. So I have 4 triangles there. We know that the sum of the angles of a triangle is 180 degrees. So the sum of the angles in a hexagon is 180 times 4. So that is 180 times 4. That's going to be 720. That's the sum, is 720 degrees. If I wanted to find the measure of one of those angles, I take the sum and I divide it by the number of angles, which is the same as the number of sides. So I take 720 divided by 6, and that's going to be 120. That's each interior angle is 120 degrees. Now for exterior, basically the sum of all the angles in the on the exterior of any polygon is 360 degrees. So to find one of them, you take 360, you divide by the number of sides, and that is the sum of the exterior. For each individual angle, one interior plus one exterior is always going to add to 180 degrees, because if you look at the diagram, if I have an interior, actually let me draw it over here so that other red line isn't there. This angle and this angle are always supplementary, so they will always add up to 180 degrees. So we have to remember the formula, because I could give you a polygon with many, many sides, and you might not be able to draw in all the triangles. So the formula for the sum of the interior angles, the sum of the interior, is going to be 180 times n minus 2, where n is the number of sides. One interior angle. One interior is going to be the sum divided by the number of sides. So it's 180 times n minus 2 all over n. So if I want one interior angle of, let's call it a 49 gon, I have no idea what the official name of that is. It really doesn't matter how many side lengths if I can use the formula. The sum is going to be 180 times 47, and that ends up being a lot, 8460. So one interior angle is going to be 8460 divided by 49, and that's going to be 172.6-ish. Okay, approximately 173 degrees. So that's the process. You don't have to have the diagram to do this. You just have to remember the formula for the sum of the interior angles and a single interior angle. So the second part of this is just reviewing what we need to do to prove things in coordinate geometry. Yesterday we reviewed midpoint and distance and slope a few days ago. So we're going to use those calculations to prove things. To prove a parallelogram. First of all, to prove a parallelogram, you have some choices here. You can prove that opposite sides are equal, or opposite sides are parallel, or you could show that the diagonals bisect each other. And these take 3 different calculations. If you like the distance formula, you would use the distance formula 4 times to show that opposite sides are equal. Or you could use the slope formula 4 times to show that opposite sides are parallel. To show that diagonals bisect each other, you use the midpoint, and that's the quickest calculation because it's just 2 of them. You find the diagonals, you find their midpoint. If they have the same midpoint, they bisect each other. To prove a quadrilateral is a rectangle, you have to show it's a parallelogram and then a rectangle. A rectangle is special because it's a parallelogram with the right angle. So you have to do slightly more calculations for this. You could show that opposite sides are parallel and adjacent sides are perpendicular. This is the most efficient way of showing it's a rectangle because it's 4 slopes. You calculate the 4 slopes, and that's enough to show that the opposite ones are equal and consecutive ones are negative reciprocals. You could also show that the diagonals bisect each other. That would be midpoint, and are congruent. That would be distance. So that's a bit more work. So I would recommend just doing the 4 slopes. That's sufficient to prove it's a rectangle. To prove a quadrilateral is a rhombus has all 4 sides the same length and opposite sides are parallel. So if you show that all 4 sides are congruent, that's 4 distance formulas. That's sufficient. It's all you need to do for a rhombus. You could do the slopes, but you really need the distance to prove it's a rhombus. Now the diagonals, you could also show that the diagonals bisect each other. That's midpoint. And are perpendicular. That would be midpoint, and that would be slope. So if you like midpoint and slope over distance, that's what you would do. To prove a square, you could either show it's a rectangle, or you could show it's a rhombus. So if you show it's a rectangle, you do the 4 slopes, and then you have to do 2 distances to show that sides right next to each other are congruent. To prove it's a rhombus, you got to do, you could do 4 sides, so 4 distances, and 2 slope that are consecutive. To show that you have a perpendicular lines, or the 2 consecutive sides are perpendicular. For all of the coordinate geometry proofs, you've got to show your work, and you've got to write a concluding statement. You have to. So you would say all 4 distances are equal, therefore it's a rhombus, or opposite sides, both pairs of opposite sides are parallel, therefore it's a parallelogram. You've got to write that concluding statement or you're going to lose a lot of points on the Regents exam, so make sure you do that. In class we're going to practice the polynomial angles, and then we will work through a few coordinate geometry proofs.